Welcome to Infinite. In this video clip, we will discuss the mathematical analysis of decimation process. You'll have to refer to the waveforms that we have discussed in the previous video clip. If you remember, we have defined a signal called x dash n. X dash n was nothing but product of x of n and p of n. Once you multiply x of n with p of n, you keep only the desired samples and the remaining samples of x of n are made 0. And therefore, to get y of n, all we had to do is downscale the x dash n, and that can be done by multiplying n with dn. All we had to do is downscale the signal x dash n, and that can be done by multiplying d with n, so we get x dash n d. And because x dash n is x of n into p of n, if I replace n with nd in x dash n, the right hand side will also become x of nd into p of nd. So wherever we had n, we have replaced it with nd. So that's my y of n. Now if I take z transform on both the sides, so taking z transform of y of n, we get, so if I take z transform on both the side, z transform of y of n can be written as y of z. Whenever you write z transform, you use the capital letter, so I'm using capital Y. Y of z, round brackets, because y of z is a continuous function, whereas y of n was a discrete function. This is equal to, as per the definition of z transform, it's y of n into z raised to minus n, where n will vary mathematically from minus infinity to plus infinity. And this will further be equal to y of n is nothing but x dash of nd into z raised to minus n. N will be from minus infinity to plus infinity. Next, I'm going to say that let nd be equal to, so this nd, instead of nd, I'm using another variable m, so I'm replacing nd with a variable m, and hence wherever you have small n, it will become m by d. So I'm using a new variable for the summation, so my y of z will become a summation. The new variable will make it x dash of nd is equal to m into z raised to minus n. In place of n, we will have m by d. And see, the time limits were n equal to minus infinity to plus infinity. When n is minus infinity, m will also be minus infinity because you are multiplying by d. And when n is plus infinity, you get infinity into d, again m equal to plus infinity. So the range of m will be exactly same as range of n. This can further be written as summation. Now let us again replace this m with n. M, please remember, is a dummy variable, so I can have any summation variable that I want. So now what I'm saying is, instead of writing m in this new expression, I will simply replace every m with small n, so I get this particular form. So my y of z is now defined in the form of n. But what is the difference if you compare between the previous summation expression and this one? I have managed to get this d out of the brackets of x dash, and this d is now in the power of z in the form of 1 by d. So that is done through this simple mathematical replacement. Alright, so this last step, I hope it is clear. We have simply replaced small m everywhere with small n. That's it. Now further, I can write y of z is equal to summation. X dash is nothing but x of n into p of n. So x dash n is nothing but x of n into p of n into z raised to minus n by d. And summation will be nothing but n equal to minus infinity to plus infinity. Now let's try to recall the nature of p of n. If you remember, p of n was nothing but a periodic signal in which the first sample was equal to 1 and remaining all samples were 0. So when was it 1? It was 1 for n equal to 0, comma plus minus d, comma plus minus 2d, comma plus minus 3d, dot dot dot, and it was 0 elsewhere. Please have a look at the waveform p of n, or try to recall p of n. If you remember, it was 1 at n equal to 0. The next value of n at which it was 1 in that case was equal to 3. But that is because the value of d was 3 in that case. We had drawn the waveforms considering d equal to 3. Next sample which was equal to 1 was for n equal to 6. So that will be 2 into 3 will give you 6 again, because d is equal to 3 again. So you can see if d is taken as 3, then p of n will be 1 at n equal to 0, 3, 6, 9. And this will also be the case for negative values of n like -3, -6, -9, especially when you have signals defined on both the sides. But everywhere else its value will be equal to 0.